So we're going to be looking at voltage, energy, and charge. We're going to be watching a video. You can just relax through the video at first. Okay, watch it, see how it goes, and then we will talk about it. Yes? This is on page, is it 74? 74. But like I said, the first time we watch the video, you're just going to watch it and take it in. Okay?
In this segment, I'm going to deal with the basics of electricity.
Silly me, because I had a test going on first block. Okay, why are we still muted?
Electricity.
Okay.
In this segment, I'm going to deal with the basics of electricity. I think it's easiest to think of electricity in analogy to a river or a creek. A fundamental quantity in a river is how much current is flowing. In other words, how much water is passing a point in a second. With electricity, current is also really important, but now we're talking about charge that passes a point in a second, not water. We measure that charge passing a point in a second in coulombs. So the current, which is given the symbol I, should be measured in the number of coulombs that pass a point in a second. Just like in the river, we might measure the amount of water that's flowing past a point in the number of buckets of water that are passing a point in a second, say 15 buckets a second. In a wire, we'll count the number of coulombs that go past a point, and that is the value of current, say 3 coulombs per second. A coulomb per second is...
Does anyone know what a coulomb per second is? There's another word for it. It is a amp. Yes, amp or ampere, yes.
Is given a special name. That name is an amp. But you must never forget that what an amp means is it means a coulomb passing a point in a second. So if there's a current of 5 amps flowing, that means 5 coulombs are passing a point in 1 second. Current is the easy part of electricity because I think it's not too difficult to think of the number of coulombs that are passing a point in a second. Voltage is a little bit trickier. Voltage or potential difference. I think the best way to think about that is to think about a lake. If we had a lake, there would be no current flowing.
Why is there no current flowing in the lake? Chat with your neighbor about that. Why is there no current flowing in the lake? I'll come to you when you answer.
Yeah, the lake is like
Okay, Max, what do you think? Yeah, it's not that there's no potential energy, but there's no difference in potential energy. It's all at the same potential energy. If you were to dig a drainage ditch out the side, then you would have a difference in potential energy. But because it's all level, there's no difference in potential energy, so it won't flow from high potential energy to low potential energy because it is all the same potential energy in the lake.
Why is that? The reason is because the bottom of the lake is flat. If you were to pick up one side of the lake and lift it up a little bit, then the water would start flowing down towards the other side. What you've done is you've created a difference in potential, gravitational potential energy. The side that you've lifted up now has more gravitational potential energy than the other side. So the water will rush down from higher potential to lower potential. In electricity, it's a very similar thing. The way we make current flow is we produce a potential difference in the wire. Not a gravitational potential difference, though, this time, an electrical potential difference. The way we can do that is with a battery. With a battery, that's like picking up one side of the wire and putting it at a higher electrical potential than the other side of the wire, the other end. So electrons will tend to flow from the higher potential down to the lower potential. And the greater potential we apply, the more the electrons will flow, the greater the current will get.
Now, for those of you who aren't watching this, there's a lovely little animation that you are missing. So don't miss the animation. Orna?
So electrons will tend to flow from the higher potential down to the lower potential. And the greater potential we apply, the more the electrons will flow, the greater the current will get. In a very similar way to the river. The greater the difference in height in the river, the more the current will flow. So why do we use the word potential? What does that mean? The word potential refers to the potential to do work. The potential to do work is given in units of joules per coulomb. That is, the energy per unit charge.
Okay, so remember last day we talked about energy, abbreviation E, in joules, joules J. And when we start looking at voltage, which is the potential difference in electricity, we're going to say how much energy is stored in a bucket of electrons. Yes? Energy is measured in joules. Buckets of electrons are really called what? Tell your partner, what are buckets of electrons called? Coulombs. So we're finding the energy in a bucket of electrons. We're finding the joules per coulomb. Okay?
But 1 joule per coulomb is given another name. It's called a volt. But you must remember, if someone tells you that there is a potential difference across a wire of 10 volts, that means that 1 coulomb of charge at the higher potential end can do 10 joules of work on its way down to the lower potential end. Or it can do 10 joules of work more than the charge, 1 coulomb of charge, at the lower potential end. So let's think about this as an example with a 1.5 volt AA battery, a standard battery. What does that mean, that it's a 1.5 volt battery? Well, it means that if 1 coulomb of charge came out of one side, it could do 1.5 joules of work before re-entering the other side of the battery. So if you connected the battery up to a little light bulb, each coulomb that came out of the top of the battery and went through the light bulb would give off 1.5 joules of light and heat before it re-entered on the other side. So, to summarize, there are two fundamental quantities in electricity, current and voltage. Current is the easier one. It's just the number of coulombs that are passing a point in a second. It's given the letter I, the symbol I, and its units are amps. But don't forget, 1 amp just means a coulomb per second. Voltage is a little bit trickier. Refers to the difference in potential to do work in a wire. The difference in electric potential. It's measured in the number of joules per each coulomb. But that is given the special name, the volt. The greater the amount of voltage that is applied across a wire, the greater the current that will flow in that wire.
Okay. So, get back to page 74. Some of this is... Uh-oh.
Hey there.
No, thank you.
In this segment, I'm going to deal with...
I just want to minimize it because I don't want to have to find it again for next class. Okay, here we go. So just to summarize the video, remember, if the bottom of the lake is flat, how much flow is there in the lake?
The same.
Is there any flow of water? No, because there's no potential difference. But if we were to pick up one side of the lake, the side that is higher up would have a high gravitational potential. And the side that was lower down would have a low gravitational potential. Where is the water more stable?
At the bottom.
At the bottom. Okay, so we have, this is stable. This is unstable. And things naturally travel from an unstable state to a stable state. Whoops, wrong way around. And when I say unstable, what kind of potential energy do we have? High or low? High. Do you know what I mean when I write PE? Potential energy. Okay. So they naturally move from an unstable high potential energy state to a stable low potential energy state. And the result is the current flows. Okay. Now we're going to do the same thing with electricity, but in this case, we are essentially lifting the electrons up. We are going from an area of high electrical potential, which is unstable, to an area of low electrical potential energy, which is stable. Do you remember why the electrons are unstable up at the negative terminal? At the negative terminal, the electrons are unstable because, see if you can remind your neighbor. I'll get you, Nisha. Kanisha.
Because like the two negative charges repel each other.
Yeah, and what has happened in the battery that's making the two negative charges repel each other? What's actually physically happened in the battery? Max? Yeah, we get a separation of charge, a chemical reaction moves the electrons to the negative terminal. So if we have little electrons in here, they end up moving upwards. So at the top of the battery, there is a high concentration of electrons. Sorry. Concentration of electrons. And the electrons, what do they do to one another? They repel. Yes. So at the negative terminal, the electrons are really unstable because there is a high concentration of electrons, and those electrons then repel each other. Why is there such a high concentration of electrons at the negative terminal? Because the chemical reaction moved the electrons to the negative terminal, okay? Now down at the positive terminal, are there many electrons or not many electrons?
No.
Not many electrons. So how would that be for new electrons coming in? Would they find that a happy place to be or an unhappy place to be? They would find that a happy place to be. So that's going to be a very stable area for electrons to move into. So like the river, the greater the difference in height of the river, the more the river will flow, and the greater the difference in voltage, the potential difference, the more the current will flow. And this brings us to the concept of volts. If you have 10 volts, do you remember what a volt is? 1 volt is equal to what? What are the other units we can express it as, Max? It is joules over coulombs. So if we have 10 volts, that means we have 10 joules in every 1 coulomb of charge. So if we give something 10 volts, that means it can do 10 joules of work as it travels through the wire to a lower potential. Okay. So the word voltage, it just means the potential difference. I guess I should have written that it is the difference in potential energy, and it is the potential to do work. And it is the potential energy contained in 1 bucket of electrons. So the potential energy is measured in joules, and the bucket of electrons, of course, is the coulomb. Could you remind me, what do joules measure? What quantity do joules measure? Joules are the unit of something. Good guess. So if it's potential energy, then we could just say it is Energy. Okay, joules is the unit of energy. Do you remember the abbreviation for energy? E. That's a nice one, isn't it? Okay, and coulombs are the unit of charge. And what is the abbreviation for charge?
I.
That one's current. I know it's one of those weird ones, right?
Wait, is it like R or something?
It's close to R in the alphabet.
Oh, it's S.
It's not S, it's the other way. It's Q. Okay, charge. So joules are the unit of energy, coulombs are the unit of charge, and volts are the joules per coulomb. It's the energy contained in the charge. Okay. All right, so let's look at this one. The guy on the video talked about this, but he didn't actually show it. So what happens is that the electrons down here have 0 joules of energy. That means they are at their lowest potential, okay? So that would be the ones down here.
That's it. Electrons down here have 0 joules of energy.
0 joules of energy?
What's that?
Oh, that's a 0.
Oh, it's 0.
I often will write the 0 like that just because otherwise it looks like an O. Yeah. Can you tell by looking at the battery how many joules a bucket of electron has by the time it gets to the top of the battery? So electrons up there have 1.5 joules of energy per bucket of electrons. Because of course, if you have more buckets of electrons, you will have more energy. So here we go. We're going to follow this little bucket down the wire. Here it goes down the wire. It starts with 1.5 joules of energy. Here, our little bucket. It still has 1.5 joules of energy. Now, to be honest, there will be a tiny loss of energy just because electrons flowing through a wire, wires are not perfectly conductive, so they will be a little resistance, and so they'll bump into atoms every once in a while and a little heat will be generated. But you're going to end up with almost all of the 1.5 joules still left in the bucket of electrons by the time it gets to the light bulb. However, in the light bulb, what happens to that 1.5 joules of energy? We get heat, we get light. Those are both forms of energy, yes? How many joules of heat and light do we get? We get 1.5 joules of heat and light produced. So by the time the bucket of electrons gets out the other side, now it has, how much energy is left? 0 joules left. Okay, and then the reason it keeps moving is because you still have those electrons up at the top that want to get to that stable place. And if you imagine this circuit, there are electrons everywhere. You can't, if you're an electron, you can't move without bumping into the electron in front of you. Yes? And so if you don't want to move, if you're just like, oh, I have 0 potential energy, I don't care if I move, but there's someone behind you and they're going bump, what are you going to do? Bump. You're going to continue moving, yes? So it's a continuous flow and it's always the same speed all the way around. And the reason it's the same speed all the way around is because, well, if you imagine that there was like Ms. Spence's all the way around the room, I used to have students stand up and do this, but nobody seemed to like it. Would you like to do this? I got 1 yes, but we need like a circle. So unless I get everybody saying yes. Yeah? Okay, because what we're going to do is we're going to act out current. Yes? Can we all do this? So everybody stand up, and we're going to make a circle around this set of desks here. Okay? Okay, so everyone circle around these desks here.
George might actually need the legs so hard today, bro, in practice. Like, yeah, Tony trusts you with that. Tony feels like body. Very smart.
Just trying to circle.
Wait, Mike, wait up.
Okay, now let's say that I am at the top of the battery. Okay, so I'm just going to go, and when I
Yo, what the
oops. Now you need to get bumped all the way up to me because like you really good. Okay, so we just keep going. You know, instead of being quite so physical with bumping, we're just gonna like push each other along. So push, keep going. The electron behind you is pushing you along. Keep going. The electron behind you is pushing you. What's possible to be flowing faster over there than flowing slower over here? Would it be possible? No, it can't. Okay, that's why the current is always the same in a circuit everywhere you go. Thank you guys very much.
I'm just saying, hypothetically, you get a different value. And necklace
Yeah. Okay, so this is just a little analogy. You can imagine if there were a river and we had a mill. You can imagine if this were a river and we had a mill on it, we would have the water up here containing 1.5 joules of energy. And as it passes through the mill, we would get some sound, we would get some heat, and we would get a lot of motion. It would drive that water wheel around, okay? And that water wheel, if we attach some gears, it could like grind flour and things like that. Okay, and by the time it gets to the bottom, the bucket of water now has 0 energy. Here's another model. Okay, so we have the water model. Now we're going to use the aura model. Do you guys know what an aura is?
Yeah.
An aura is kind of like just this sort of fuzzy energy field that you're supposed to have around you or something like that, okay? So we're using energy is going to be represented by this red aura. In your book, it is gray because so sadly, we cannot get color pages in your book. Okay, at any rate, if you want to like highlight it or something, you can make it another color. So if you wanted to say, if you have highlighters, feel free to help yourself if you want one. You could highlight this and you could highlight this. Yes. We will in a moment. You know what? I used to have a video for this, but it went away. Because it was, I think it was done in Flash, and Flash doesn't work anymore.
What's Flash?
Flash is an outdated thing that you can't use on the internet anymore because it like causes security problems. Yeah. So we have this energy cloud, which we can call the aura. And the unit of, so this is our quantity here. Is energy, and its unit is the joule. We have charge, which is the quantity, and its unit is the coulomb. So here we go. Watch the little joule of energy settle onto the coulomb of charge. Here it goes. It's moving downward. You're going to have to use your imagination. Oh, look, the joule is now on the coulomb. Okay. And eventually, in the middle here, we have our coulomb of charge. And on the outside of it, all over it, we have our 1 joule of energy, all sat on that 1 coulomb of charge. So if we were to represent 1 volt, remember 1 volt is equal to 1 something over 1 something else. Do you remember? 1 joule per coulomb. Do you see how we still have 1 coulomb, that black part in the middle? But now we have twice as much of the red aura. Yes, twice as much energy. So that would be how many joules per coulomb? That's 2 joules per 1 coulomb. So here's a little question for you. What if I gave you 6 joules of energy in total, and I gave you 3 coulombs of charge? What would the voltage be? See if you can figure that out. Once you've come up with your best guess, check and see if your partner got the same answer.
1 joule and 6 joules and 3 coulombs. We got times that right now. Just sounds good.
I'm going to start saying some numbers. And when you think I should stop, you can just raise your hand. Okay? And we're going to say, this is how many volts. 1 volt. 2 volts. 3 volts. 4 volts. 5 volts. 6 volts. Okay, a lot of people liked 2, so let's take a look and see if that is correct. Well, let's imagine that we split our 6 joules up into three equal parts, yes? So we've taken our 6 joules, and it is now in 3 equal parts. Each of those parts is how many joules? 2 joules. So each 1 coulomb gets 2 joules. So we have 2 joules per coulomb, which is equal to 2 volts. Now, when we write an equation, do we write the equation in quantity symbols or units?
Oh, we run it in quantities or units. The thing about voltage is like energy.
Do you remember?
Oh, it's fun.
So I've got 2 possible ways I could write this. I could write voltage is equal to energy over charge, or I could write it as volts equals joules over coulombs.
Okay, so
Which one should I choose for how to write the equation? Yes, the first one, absolutely. Okay? So we're going to be using our quantity symbols. Okay, so V is equal to E over Q. And how could you possibly remember this equation? Well, it's a very easy question. Okay? You don't have to memorize it. It's on your purple sheet. Okay, but if you're interested in that kind of thing, you remember what the other formula we used was? I quit. And then when you say, I quit, Ms. Fenster says, no, don't quit. It's a very easy question. Don't quit. It's a very easy question. You can do it. Okay? Very easy question. So we're going to basically use guess CUBS again. Okay? I need to really update this. Let's see, we have G, the given information, the U, the unknown. So we have our given, we have our unknown. We're going to write the equation. We will solve it for the unknown. We will substitute in the values. We will do the calculation and make sure that we include units. And we will box our final answer. And I think I forgot to update this. 7 is to, we have gas, cub, we're going to stop at a reasonable number of digits or sig figs. And if any of you are doing sig figs, you also want to make sure that if you can, that you are rounding correctly. So that would be, you would want to take a look at 6.2G, which is rounding numbers. It's not much different from math. So if you take a look at it, that could be a little other enriched stuff you could do. Okay, so shall we try a question like this? Okay, here we go. Oh, why did I leave this in here? This makes me so sad. Okay, so you know what I'm going to do? You're going to go get a piece of paper, and I'm going to take this question. So go get yourself a piece of paper. There's lots of paper just back there. Oh, thank you. There you go. So you are going to take that piece of paper and you're going to cover up the answer, and we're going to do it together, okay? But remember, the entire thing will be in your book when you need it, okay? So you're going to leave it so that you can see this, so that you can see the question. You're going to cover up the rest of the page with your piece of paper. Does that make sense? If you don't understand what I mean, call me over. I can move the piece of paper for you. Okay, what do we do first? We write our given. G for given. And remember, when you write your given, you are going to write it as quantity is equal to a number with a unit. So could you please try to write down your 2 given pieces of data? And please feel free to have your purple sheet out. If you forget what the symbol for charge is, you can look on your purple sheet. Anyone missing a purple sheet today?
I know, very buttons in radio, but I'm so horrible.
Anyone missing a purple sheet? There you go.
Anyone else missing a purple sheet?
I think so.
There you go.
I won't be surprised if it's still.
What is the symbol for charge? Charge is Q, quantity of charge. So we are going to write Q as our quantity, which means charge, equals, and then the number is 3, and the unit is, what's our unit? Coulombs. So we're going to write Q is equal to 3 coulombs. That's our first given quantity. We have 6 joules. What is the symbol for energy? E. So we're gonna write our quantity, which is energy, equals, and then we're going to write our number and our unit, 6 joules. What comes after writing our given quantities? Yes?
Writing the unknown.
Writing the unknown. And when it comes to Thursday's quiz, if you would really like to have fill in the blank guess cubs, let me know and I can make you a version that has like, it says given and then it says quantity equals units. Okay, let me know if you want that, okay? I won't provide it for you unless you let me know ahead of time, okay? So we still need to do our quantity. And then it's going to be equal to, we don't know how many, and then our unit. If we don't know the unit, we can leave it blank. Okay. So could you please write down your quantity of your unknown? And remember, when you're looking for your unknown, look for the question word. What's our question word in this question? Yes?
Voltage.
Yes, we got what? What voltage? Okay, that is our question word right there. So our voltage, now I don't know if I officially mentioned this, but the abbreviation for voltage, you can look it up on your purple sheet, but the abbreviation for voltage is, guess what?
Yeah.
V.
Oh, yeah.
This one's nice, actually. So the symbol for voltage is V. So we're going to write V, voltage, is equal to, we don't know how many. Now, can you guess the unit for voltage? This one's actually really easy. It's literally volts. Like that? Okay, so what we've got here is we've got voltage, stupid pen, is equal to, I don't know how many volts. So the symbol for the quantity and the symbol for the unit are the same. And if you forget that, where can you find it? On your purple sheet. Okay. So that's our given, that's our unknown. We are going to, where's our next thing? What comes after U? E. So we need an equation. And what you can do is you can look and you can say, I have 3 letters. I have Q, and I have E, and I have V. I have 3 quantities. There should be a formula that relates those 3 quantities. And if I don't remember it, I can look on my data sheet. We want one that relates Q and E and V. So you pick the correct one from the top of the page. Should we pick formula number 1? Should we pick formula number 2, or should we pick formula number 3? Number 2, okay, the very easy question. So we have V is equal to E over Q. So that's our equation. Do we need to solve, or have we already solved for the unknown? Who is the unknown? Who is the unknown? Voltage. Okay? That is our unknown, is voltage. Do we need to solve for voltage, or has it already been solved for? It's already been solved for. It is in the correct form already because we have V by its on the top, by itself, and on the left. Okay, so we don't need to solve. That's already done. Okay, so now what we have is we are going to, what comes after solve? Substitute. So if we substitute E, what would we put in for E? Go back to your given quantities. What can I substitute for E? E equals what? 6 joules. So we're going to put 6 joules in. Okay, Q. What can we substitute for Q? Yep, that one, 3 coulombs. Yes, absolutely. So we're going to substitute in 3 coulombs. So that's our guess. What comes after guess? CUBS. What does C stand for? Calculate. So you're going to do the numbers. What are you going to do? You've got 6 over top of 3. That means are you multiplying or dividing? Dividing. If one number is over top of another number, you're going to divide. What is 6 divided by 3? 2. Does that look like a reasonable number of digits to you? Yeah, okay. So that's fine. And then our unit, because we have CUBS, what would our unit be? We can either write it as joules over coulombs, so joules over coulombs, or we can write it as 2 volts, because volts means the same as a joule per coulomb. And then we have to remember to box our final answer. All right, and what I would like you to do is I would like you to do pages 80 and 81. Okay. What you don't get done today, you could please do for homework. Solve for R. That one is not correct. Thank you. Yes, let me just write that one down so I don't forget to change it.
This is when I took all his walls. So much. I have all these walls.
Yeah.
I was like, he's got a boss. I pickaxe his walls. Yeah, I kept on like making windows.
Okay, so we
Well, I have to show you my experience. I'm crazy at those. That won't be one name on something. You watch? Like Nate Great on it. So yeah, good. I'm gonna watch that one. I don't know what Hey, that was oh, oh, I think it was like my 4 days. Oh yeah, I actually listened to it. You can do that?
Yes.
Go to party settings. Go to the settings. On party chat? Yeah, party chat. And then go to voice. Allow your voice. Share your voice. I could have got so many clips on raging. Oh, he turned it off. We got oh, we pretended to say it, send it to our voice. Hell, I live up here. Yeah. And also, you go to capture office because you don't have the mic on of the party. That's like how you include your own mic on settings. Like you go to the capture. Like you press the capture button, go to the right, and include the mic audio and the party's. Oh wait, I don't think the settings for PlayStation. Oh, it is? Yeah. Oh.
Yeah. Yeah.
Right, it's a lot of bullshit right now.
Yes, it is. Yes. Yeah. Oh, by the way, I just wanted to let everyone know that if you want to do test corrections for Unit 4, I am here tomorrow morning. I'm here Thursday morning. I'm here after school today. And if you can't fit it in any of those times, there is the afternoon of the Thursday. I know that it's like, what do they call it now? Winter Wonderland or Sound is Winter Wonderland? Okay, there's Winter Wonderland, but if you want to take, say, a half an hour of that time, because it's all afternoon, right? If you want to take a half an hour of that time, maybe nearish the beginning, so then you can go enjoy yourself. And then I don't have to worry about being out of the room. You could come and do corrections at that time also, if you would like. Okay? Yes. Okay. Here, I'll write it down. Overhead.
But the app only shows you like black and white. I have I didn't even flip that. Logan, I was playing with Alex, but he didn't want to play. No, this is great.
Are you new to this stuff? I will just skip that because that's unnecessary.
Still
Do
good.
it. This is pure good. Okay, so six.
He's bad, but like,
Now we've got it for 1 minute.
it's so fun.
Yeah.
I just put on the I have to me like rubs. It's so fun. Muhammad was me at the time.
My God. By the way, in the extra practice, the answer key for number 6 is wrong. I apparently didn't solve it at all. I just left it the way it was, which was kind of foolish of me. Okay?
The quizzes on Thursday?
Quiz is on Thursday.
Do you have any practice sheets that I can do, or do I have to go all the way back to it?
So what you would do for practice is you would do this. And then you would also be working on this because this is basically practicing guest CUBS. So pages 80, 81, and then 82, 83 will also be,
Okay.
yeah?
Yeah.
So these are all just guest CUBS.
Okay.
Yeah.
Are these gonna be like the questions on the quiz?
Yep.
Okay.
Pretty much exactly. Yep. And don't forget, we have a quiz on Thursday. Not a long one, just a short one.
Like doing like this.
Mm-hmm.
Does the order matter?
No.
Okay.
Yeah, it's because 2 times 3 is the same as 3 times 2, so it doesn't matter.
Okay.
Yeah?
Yeah, I have a dentist appointment.
Oh, yeah, no worries.
And I also have one tomorrow during Friday.
It's okay. You know what? We're just kind of floating through this unit. I've got 8 people away in my next block. So I'm kind of like, whatever you get out of it, you get out of it.
Okay.
Right? Yeah. So don't stress over it. Okay? Yeah.
I just wanted to let you know it'd also be a way to.
Yeah. No problem.